Good morning, guys. This is the video explanation for the first 9 weeks test review for Algebra 2. So let's go ahead and just jump right into it. Number 1, the inverse of 7 and negative 9 is which of the following? A quick refresher, if you don't remember what it means to have the inverse, it means basically that you have an x value and you have a y value, like we do here. So we have 7 is our x, negative 9 is our y, and all you do is switch them. So make a little note to yourself. Inverse means to switch in the x and the y values. If I do that, I get negative 9 comma 7, which lines up to choice B. So far, so good. That's an easy one. Hopefully you remember that for the test. Same idea here. Here I have which graph is the inverse of the function represented by the equation below. So first thing I'm going to do is I'm going to substitute the f of x notation and make it a y. So that way now I can go ahead and easily create the inverse. If I switch the x and the y values, so these two switch places, I will then end up with the equation that says x equals 2y plus 8. Now I want to isolate the y so I can get it in slope-intercept form so I can best identify which graph matches this from below. So I'll do that by subtracting 8 from both sides. On the left side, I now have x minus 8 equals 2y because these 8's cancel out. Y is still not by itself, so I'll divide every single term by 2. Remember, this x really has an invisible 1 in front of it. So after everything gets simplified, I get a 1/2 x, which is my slope. I get a negative 8 over 2, which is a negative 4, equals my 1y. So now I'm looking for the graph that best represents this equation. So what I'm going to do is kind of zoom out a bit here, and we'll move up a bit. I need a graph now that is going to, first of all, have a y-intercept of negative 4. So that's here. Choice D, C, and A. Choice B is out because it crosses way up here in positive 4. Next, I need a slope of 1/2. Positive 1/2 means my graph is increasing from left to right. That takes out choice D. So now I have to just basically understand what this slope of 1/2 means. That means I'm going to rise up 1 unit and then move to the right 2 units before I get to the next point on the graph, which is choice C. Choice A has it backwards. Choice A goes up 2 over 1, and that's wrong. So choice C is the correct graph for the inverse function of our formula. Next, number 3. Let me go ahead and kind of zoom back in there to give myself some room. All right. And here we go. Number 3. If f of x equals 6x plus 36, which of the following functions is equivalent to the inverse function of f? Same thing like the last problem. I'm going to first take this f of x notation and turn it into a y. Y equals 6x plus 36. Then the inverse tells me to switch both of these variables. So I get x equals 6y plus 36. Now isolate your y, get the y by itself. I'll subtract 36 from both sides. And I get x minus 36 on the left equals this 6y falls down, and these 36 cancel out to 0. Now I divide every single term by positive 6. Remember, there's an invisible 1 here in front of the x. So now my equation is 16x. Negative 36 divided by positive 6 is negative 6. 6 divided by 6 is 1y. So this equation is represented right here as g of x, 16x minus 6, choice C. Moving on to our next problem here. Determine if the following functions are inverses of each other. Use the composition of functions. So if you don't remember, what they're going to want us to do for the composition of functions is basically take the first function and put it inside the other function. But what we get out is what's important. If we get a single x by itself, then we get a yes answer, that they are truly inverses. If we get anything else, then the answer is no. So I guess I'll put it in anything else. So here's what that means. F of g means we're going to take the f function and we're going to stuff the g of x function inside of it. So the f function is 4x. I'm going to replace this x with this function right here. So I get 4 of x over 4. That's what I get when I stuff the g function inside the f function for x. Now I'm going to go ahead and just multiply this out. What I really have is just 4 over 1 on the outside times x over 4 on the inside. Multiplying fractions, the rules, which I'm sure most of you don't remember, is multiplying straight across. 4 times x. straight across the bottom, 1 times 4. I'll simplify. 4 divided by 4 gives me 1x, or in other words, a single x. So yes, these are inverses of each other. Moving on to number 5. The question here is, the graph of f of x is shown in the coordinate plane below. Which of the following best describes the graph of f of, and these should be absolute value bars. So our absolute value of x minus 3. Well, when we have the absolute value of x minus 3, that means it's going to be shifted to the right. Now, we have no other number in front, so it's going to be the same basic graph with no change. So it's going to have a vertex at 3, 0. That takes away that choice and that choice. And choice B says neither wider nor narrow. That means there's no change in how wide or how tall or whatever, how it looks. It would be the same V, just shifted over to the right 3 squares. So the minus 3 has the effect of moving it positive 3 to the right. Don't forget that little trick there. Number 6. Which of the following functions has a line of symmetry at x equals negative 3? So we have absolute value functions. Here's what's going on. I'm going to draw a graph to explain what is being described here. So we have our coordinate plane. Absolute value graph we know is going to be a V. All these equations here are positive, so the V is going to be opening upwards. It tells us it wants us to have a line of symmetry at x equals negative 3. Negative 1, negative 2, negative 3. So right here, it's going to be an invisible line, basically, that divides our V into perfect equal pieces. So we're going to have something that looks like this. So what equation would you need from over here on the left-hand side out of all these that would just move your absolute value equation 3 squares to the left? Well, if you add plus or minus 3 to the outside of your absolute value bars, that raises and lowers. But if you have plus and minus inside the absolute value bars, that moves it left and right. Remember, it's counterintuitive. Although we're going negative 3 squares to the left, it's going to be represented as a positive 3 inside the absolute value bars. So choice B is our best answer, or is the correct answer there. For choice C, same type of question. Which of the following functions has a minimum at 5, 0? So they're all absolute value graphs, we can tell by the answer choices. So we're going to have a V that does not go any lower than the point 5, 0. So if I go to 5, 0, 1, 2, 3, 4, 5, I'll put a point there. There's my vertex. It has a minimum. So the graph goes up infinitely from going to the left and going to the right, I guess. But it does not go any lower than this point at 5, 0. So just like the last problem, we have a shift over here, 2, 3, 4, 5 to the right. The only way you get a shift left or right is when you have plus or minus inside absolute value bars like you do here and here. When it's outside the absolute value bars, that moves it up and down. So in this case, it's counterintuitive. Remember, it seems like the opposite. 5 positive means we're going to have a minus 5 inside the absolute value bars. So choice D is your correct answer for that one. For number 8, this one is extremely complicated. And if there is one like this on the test, I am going to count it with the most minimum of points because I believe this one's a little bit more than what we want, or than what we've looked at before. But here's what we have. So we're given basically I'm going to make a grid. We have this graph, 3x. So what we have is a line that has no y-intercept. So basically we have the equation y equals 3x plus 0, because it has no y-intercept, or the y-intercept is 0. Goes through the origin, up 3 over 1, up 3 over 1. That's fine, that's what 3x plus 0 means. What they want us to do is get a new equation, so I'll call this, let's just call it z, I guess, whatever. And then it wants us to have the same function, the same line, but it's going to be moved up 4, so it's going to have a plus 4 of a y-intercept, but left 5. So if I go, actually I'll wait on that part of the equation there, because that's still kind of an incorrect idea. Let me erase this really quick. So here's what's going on. So here it was originally the y-intercept. It's going to go up 4, so I go 1, 2, 3, 4, let's say, and then left 5. 1, 2, 3, 4, 5. So here's its new point that it's going to go through. So we have a line that goes through here. All right, so the coordinates here would be negative 5 because we went 5 to the left, and positive 4. So originally, I had a 0, 0, I guess, intersection, y-intercept, or point. Then I have this other point that caused it to move over to negative 5 and 4. All right, so then what I went ahead and did now is I went and I told myself I'm going to go ahead and take the new equation, y equals 3x plus 4. Actually, you know what? I realize now what I did is not going to be as accurate as I thought it was going to be. So I'm going to go ahead and give you the answer that I got and try to explain it the best I can. And I'm going to tell you guys right now, if this comes out on the test, I'm going to go ahead and just not count it at all because I don't even remember us doing this and I can't recall exactly. I'm not sure this question is as clear as I need it to be, but I'm going to go ahead and just try to give you what I got. My choice was choice B, and the reason was because if I'm going 5 to the left, that'd be a plus 5, so I believe it's going to be something mirrored to our absolute value, although it says we have a linear function. I was trying to prove it over here with some math, but I realized I'm going to probably lose the whole class. So I'll just go ahead and describe what my rationale was for number 8. So I would tell any student, I guess, first of all, we have the same width for each graph, so I'm not worried about that 3. We're going 5 to the left, so just like absolute value, I figured the plus 5 is going to be our first choice, which kind of gives me this choice already. The plus 4 is the 4 units up, because like absolute value, the numbers on the outside move up and down. So I'm going to go ahead and just say, let's stick with B. And if something like this comes out on the test, I will mitigate it with the grading. Because this one I think is not anything we have practiced this 9 weeks that I can recall. All right, let's go ahead and move on with the rest of this review. Number 9, this one's a good one. So what we have are 2 inequalities and they want us to match the graph. Best way to do that is to get them both into slope-intercept form. So what I'm going to do is I'm going to take the first inequality, and y is almost by itself. The only thing is I have a 3y, so I'm going to go ahead and divide every term by 3. And since it's the positive 3, there'll be no sign change. So I get a single y is greater than or equal to, remember there was a 1 in front of this x, so I have a 1/3 x plus 6 divided by 3 is 2. So I need a solid line, because that's what this symbol tells me, that's going in a positive direction that crosses at positive 2 on the y-axis. So if I go ahead and I look at my graphs, I'm looking for one that crosses at positive 2. So I'll go ahead and see, let's see, from choice A, 1, 2, there is a graph there. 1, 2, there's a graph with a line there. Choice 1, 2, there's a graph that has a y-intercept there. And choice 1, 2, nothing there. So this graph is out already. Next, I know I need to have a 1/3 slope. That means wherever crosses the y-axis, it has to go up 1 square over 3 for the next part of the line to occur. This one does not seem to have it. If I go up 1, 1, 2, 3, this one seems okay so far. And this one, up 1, 1, 2, 3, and that one seems okay so far. So I can't really tell if the lines are solid or dashed, so I'm going to kind of just use my next line to figure out which of these two, because I seem to narrow it down, is the best one. So for the second line, what I'm going to do is I'm going to take the 2x minus 3y. What I want to do is make that 3y positive. I'm going to do that by adding 3y to both sides just to move it over. Because I'm adding and not multiplying or dividing, there is no sign change. So now I get 2x is less than a positive 3y minus 9. Now I'm going to go ahead and add 9 to both sides. When I do that, make a little colon here to continue my expression, I get 2x with a plus 9 on the left is less than 3y because I added 9 to both sides. Now I divide everything by 3, every single term, and I get 2/3 x plus 3 is less than y. Whoops, my y didn't come out there. There we go. So I need to look for another line between these two that crosses at positive 3. So if I go ahead and, let me go ahead and zoom in a little bit, move this graph, these two graphs up. So positive 3, positive 1, 1, 2, 3. Here's another line that crosses at positive 3, and here's another one here. Now I need one that has a slope of 2/3. So that means up 2 over 3. Up 2, 1, 2, 3. And then I have, for this one, up 2, 1, 2, 3. And so what I have now is I have to look at the shading. And the shading says for this one, y is going to be, let me move it back down. For that second line, y is greater, so everything above it should be shaded. So I have that here. I have that down here. And then I also have that up here. For my first graph, it was y is greater than also, so everything above it should have also been shaded. So I have that up here. So the choice I get is choice B. And I'm going to go ahead and verify that. Actually, no, that should work. I'm not going to go ahead and verify that. I think I did my work already. Let's go ahead and check our next problem. Number 10, same thing again. We have to match it. So what I'm going to do is, I have one line that's already in choice A, B, C, and D, already done in slope-intercept. All of them are a line that crosses at 1/2 x. So I need a line that crosses through, and they have no y-intercept, if you notice that. None of these up here. Plus 0, I guess, in other words. So they all cross through the origin. All right, so that's this line I'm talking about here. Well, let's look at it. We know that it has to be positive, so I should have a positive 1/2, which they all are, up 1/2. I also need to see where it's shaded. Everything from this line is shaded below, so that would be a less than. And it is going to be a solid line, so we have a less than here, and we have a less than here. These are greater than, so I'd be shading above it, which would be up here too. That's not happening. So these two are out. Now it's between these two below, so I need the equation of this line right here. And looking at all the symbols, it is a solid line that crosses at 2 units above, so that's a positive 2. So I need a plus, I need to get a plus 2 somewhere. Here's a positive 2 here, and here's a positive 2 here, so that's not going to help me. Now I need my slope. My slope needs to be up 1, 2 over 1, so I need a positive 2 slope. But both equations don't have the y by itself, so I'll go ahead and subtract 2x from this one from both sides, and I get y is less than or equal to negative 2x plus 2. And on the second one, I'll add 2x to both sides, and I get y is less than or equal to 2x plus 2. Well, looking at my graph now, I can see that everything, first of all, I have a positive slope, so the only one that has a positive slope is right here at choice B. So this would be the correct one, plus everything is also shaded below that line. So that gives us this solution zone right here. All right, some basic, I guess, just refreshers. If there's a solution point when you have systems, then your two lines will be intersecting. If there are no solutions, then the two lines would be parallel. So intersecting, you'd have two lines that cross somewhere at a certain point. Parallel lines, obviously you know what that means. You have two lines that never meet. And if there are infinite solutions, the two lines are the same. So you're going to get the same line that on top of itself, basically, as far as the graphs go. As far as the answers you get, here you'll get an x and a y point. If they're parallel, you'll get something like, for that one, it would be something like, let me take the coordinates off. You get something like x, or no, you get two numbers. You get like 5 equals 3, something that's not true like that. So that means they're parallel, there's no solution, they never meet. And if they're the same, you'll get the same thing like 2x equals 2x, or something like that. You get the same exact thing on both sides. That's how the math will work out. So keep that in mind when you check your solutions. Number 12, and hopefully we are getting kind of close to the end there, thank God. So if y equals x squared minus 2x plus 10, then find f of negative 3. How funny that they put this in y and this in f notation, but we know what it means. Change the x to negative 3 and just PEMDAS this. So negative 3 squared minus 2 times the negative 3 plus 10. Negative 3 times negative 3 is a positive 9. A negative 2 times a negative 3 is a positive 6. We have a plus 10 at the end. Now we just do addition. 9 plus 6 is 15, plus 10 would give us 25. That should be an easy question. Hopefully no one misses that one if it appears on the test. Number 13, our final one. It's a system. It wants to find the b value. I can already tell that if I look at my b values, I have a positive 4 and a negative 4. Those are opposites. So if I add both equations, I can cancel out the b's right now. 2a's plus 4a's gives me 6a's. Plus 4 and a negative 4 added together cancels out, so I have no b's left. Equals positive 20 plus a negative 32 equals a negative 12. Divide everything by 6. And then I get a equals negative 2. So I'll take my first equation, which said 2 times a plus 4 times b equals 20. I found out that A is negative 2, so I'll plug that in right here. So I get 2 times negative 2 plus 4 times B equals 20. To figure out what B is, I'll do the math all around this. 2 times negative 4 is a negative 8 plus 4B equals 20. To cancel out negative 8, I'll add 8 to both sides. When I do that, 4B falls down. 20 plus 8 is 28. I'll now divide everything by 4, and I get B equals 7, which is not on here. What did I do wrong? Let's see. I have my work here. I love how fast I went through this like a fool, and then I didn't realize I did my math wrong. So I have the 20, and then, let's see, negative 2, 2 times, that's what happened. I don't know why I put negative 4 there. So that's 2 times negative 2. That's a negative 4. I should have added 4. So let me go ahead and just erase all this. So even though I've been doing this for many years, apparently when you rush, you tend to still make mistakes, as I just did right now. So I hope you appreciate at least the humility in me admitting it. So I'll go a little slower. 2 times negative 2 plus 4 times B equals 20. 2 times negative 2 is a negative 4, which is what I needed to get my correct answer. Equals 20. I'm going to add 4 to both sides. As I take my time, I then cancel this out. I get 4B equals 24. Divide both sides by 4, and now I get an answer that's not only acceptable and correct, but it's actually an available choice, which is choice B. So I'm not gonna lie to you guys, that was a long review, and I have to pull it all out in one take, and it's not that easy. So please forgive me on the stuttering and the hesitation, and there's the bell. So have a good one today, guys. Good luck on your review and test.